Hi everyone, welcome to this video about how to simplify negative exponents. So before we get started, I want you to take a couple deep breaths, which will allow you to really relax, and it will also give you an opportunity to give yourself a little self-love. I feel like everything in life becomes a lot easier when we love ourselves. So take this minute to breathe deeply, give yourself a little bit of love, and let's make this math easy for you. When you first see a negative exponent, you might be a little bit confused. Like, how do I multiply a number by itself a negative amount of times? Like, that makes no sense. And I actually felt the same way when I first learned about negative exponents. But when I learned how they work, I realized they're actually pretty easy. Because if you have something like 6 to the negative 3, you basically just make the reciprocal with the positive exponent. So like the negative 3 becomes positive when you do the reciprocal of it. So it's kind of like the negative sign in the exponent means do the reciprocal of this exponent in the positive form. So if you had 5 to the negative 2, the negative means that you're going to do the reciprocal of 5 to the second power. If you had negative 8 to the negative 2, this negative tells you to do the reciprocal, and then this negative just works like a normal negative. So that would mean that you do the reciprocal of negative 8 to the second power. If you have 0 to the negative 9, or really 0 to any power, you'd end up with 1 over 0 to that power, which actually creates an undefined number because you can't do division by 0. So that's kind of an interesting problem. And then if you have a negative exponent that's already in the denominator of a fraction, you're still going to do the reciprocal, which means that the number that was in the denominator is going to move up to the numerator. So you would change that to be 3 to the 5th power because it takes the 3 to the negative 5 out of the denominator and puts it in the top of the fraction. And if you had negative exponents in the top and the bottom, you could simplify it just by flipping them. So 6 to the negative 1 would become 6 to the 1st in the top of the fraction. And then 2 to the negative 4 would become 2 to the positive 4 in the denominator of the fraction. And the reason why you can use negative exponents to represent reciprocals is because of the pattern that any type of exponent follows. So here I have listed out the powers of 3, but you could use any number besides 3. But when you list out the powers of 3, you'll notice that each number divided by 3 equals the next number. So like 27 divided by 3 equals 9, 9 divided by 3 equals 3, 3 divided by 3 equals 1. And if you continue this pattern and you do 1 divided by 3, that's going to equal 1/3. If you do 1/3 divided by 3, that's going to equal 1/9. And so if you look at that, you'll notice that these numbers match up with the positive exponent versions. They're just in the denominator of the fraction instead of the top or the numerator. And this is going to be true for any number, even if you chose a number like 5 or 12, or you could try any number that you'd like to. And all of them are going to follow a consistent pattern where they divide by the base. So like in this case, each number is being divided by 5. And if you do 1 divided by 5, that's going to equal 1/5. 1/5 divided by 5 is going to be 1/25. If you do it for the 12s, the consistent pattern is that you're dividing by 12, and 1 divided by 12 would give you 12. 1/12 divided by 12 would give you 1 over 144. And again, you can see that these numbers in the denominator match up with the positive exponents version. They're just reciprocals of them. And this works out really nicely when you're doing things like the product rule of exponents, because the product rule of exponents basically says that if you have two powers being multiplied together, as long as they have the same base, you can add them together. So like 7 plus 3 equals 10, which is a shortcut version for having to write out what x to the 7th means, which is x times itself like 7 times, and then multiplying by x times itself 3 times. You can see that you have a total of 10 x's being multiplied, but the product rule is a shortcut. And if you use the product rule with negative exponents and you do 8 plus negative 5, you should get x to the 3rd. And this is another way that you can see that that negative exponents should be reciprocals, because if you have 8 x's being multiplied together on the top of a fraction, and then you have the negative 5 represent 5 x's being multiplied together on the bottom because it's the reciprocal, then you can see that the x's are going to cancel out, or at least 5 of them will, leaving you with 3 x's on top, so your result is x to the 3rd. So that's another reason that may help you understand why a negative exponent is a reciprocal. And the one thing to remember is that if you have a negative exponent in the denominator, the reciprocal is actually going to put it back up in the numerator. So if you have 1 over 3 to the negative 5, that's just going to equal 3 to the 5th, because the power was already in the denominator, so the reciprocal of it is going to move it up to the top. So to summarize, the way that you simplify negative exponents is basically just changing it so that it's a positive exponent, but it's going to be the reciprocal of the positive exponent. And so if you wanted to write this in a formula form, you could say that any number raised to a negative power equals 1 divided by that number raised to the positive power. So that's how you simplify negative exponents. I hope this video was helpful for you. Please comment below to let me know how easy this was for you, and then subscribe. For more help with exponents, check out my Exponents playlist here on YouTube, or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!